All right, LeetCode problem 112, path sum. So we're given the root of a binary tree, so there's 5, and an integer of target sum, and we need to return true if the tree has a root to leaf path such that adding up all the values along the path equals this target sum. So we'll start with this example. Here's our root. It gives us our tree here and our target sum of 22. So basically we will recursively iterate through each path until we find a sum ending on that leaf node that equals our target. So we'll start at 5 and 5 to 4, so the sum here is now 5, and then here sum is now 9, and then here sum is now 20. But when we get to this leaf node, we make sure we're at a leaf node, and if we're at a leaf node, we will check if the value of that leaf node plus our current value is equal to our target, and 20 plus 7 is 27, which is not equal to our target sum. So then we'll check the right side, and here the value is still 20. We'll check here, or no, sorry, here we bring the value of 20 here, we check if it's a leaf node, and it is, and then we add it to our current sum, and 20 plus 2 is 22, so we return that. So we return true because we do have a path that the sums of all the nodes in that path equal our target. Let's see this one. Yeah, so there's no one there. That's pretty obvious. So to implement this, we'll actually create our own function to return a value for each node. It just simplifies the process, and you can just go ahead and assume that the return values of our left and right nodes are going to be a Boolean, if they do have a node or not. So we can just assume it's doing the right thing. So first we'll check if there is a node, and if there is no node, that means we don't have anything in our tree, and we can just return false. And then if that's not the case, we need to check if we have, let's see, we need to check it. We need to check if we're at a leaf node. Therefore, if there are nodes in the tree, we do have a tree, and if there's no node left or no node right, we have run into a leaf node, which means we should check if the value of that leaf node plus our current value is equal to the target. So I'll do return occur plus occur node val sum, and that'll return true or false for that current path. And then so if none of those conditions apply, we're still traversing the tree down to that leaf node. We can go ahead and add that next node's value to our current sum, and then we'll initiate what we'll recursively call on the left node, or the left child, to get its sum. So dfs, let's see, no, yeah, left. So for each recursive call, you are adding this current value, and we're getting both of those values from either left or right. So let right dfs. And then we will return, let's see, left. So for each of these recursive calls, we're checking if there is a left node or right node or child, and then we're returning which either one does have a value. So if they both do, it'll just return left and check. And then when it backtracks through the recursive calls, if it's already checked left, then it'll check the right if the right also has one. So, and then we can just return dfs with our root node and initialize our current value to 0. And that should work.